everyone, this is Nick with Tenacity.ai with my co-host Jason, and you're listening to the Cloud Cost Optimization Podcast. Today's topic, we're going to get a little bit technical. We're going to dive down into storage and the sorts of cost drivers that come with storage. Storage isn't often, for a lot of organizations, it isn't often the most expensive. There are organizations where it is the most expensive part of their cloud spending, but typically compute falls into that category. But what we see in storage is a lot of mistakes that are made in managing that storage that lead to significant cost overages over time, and they're the sort of overages that continue, or the sort of spending that continues to compound upon itself. It can get really out of control over time. So we're going to talk about some of those specific instances, what happens, and some of the things you should be thinking about. So it did happen to us, right?
It did happen, yeah.
So we had a case where our storage, we had versioning enabled and did not have lifecycle policies to cycle out that data. And what was happening was it was a part of our data staging process for loading data, which caused, that storage to explode, 50 to 100 times greater than was needed for the process itself. And, important lesson for us in creating, a model scale infrastructure. It's easy to, lose that in dozens or hundreds of buckets.
It was repeated by code.
Right. And yes, it was repeated by code. That's right.
Wasn't like there were good intentions behind the reason, right? For turning in versioning on. I mean, the reason why, you could listen to the reason why. It's like, oh yeah, that makes sense. But what's often forgot about is, well, what about the policy that deletes these things? Because if you just enable versioning, it will just grow exponentially. That's all that will happen, and it'll never life cycle it out.
I will own this. I am sure it's a bad decision I made when someone asked me, "Do we ever want to lose this data?" And I'm going, "No, of course not. We want to keep this data to train AI and so on." And didn't follow it up with, "We should probably kill that after a year of age or 30 days of age." We just it was a decision made.
But again, Nick, you're faced with a lot of the same decisions that our customers are facing, right?
Absolutely.
It's like somebody comes to you and says, "Hey, we have the option of storing every version of this file," and the first thing you think of is, "Hell, Google."
Of course.
Google Workspaces does it for me. Microsoft Word does it for me. It costs me nothing, right? It comes with the service, right? So from our context, if you don't have the deep, because not everybody's going to know that if I turn on life cycling, it's never going to, it's just not something you would know. So my point about saying that it's often a decision that's made that's with no malice is because that typically is what it is. It's somebody's like,
right.
I don't want to ever delete any of this data. Let me turn on versioning. So it starts off in this place of, I want to protect the organization most of the time, right? And it ends in a place of, holy shit, why did you make that decision, right? I mean, that's what it turns into. And so again, we talk about infrastructure life cycle. Storage life cycle is the same concept, right? The more data I'm storing, the harder it's going to be for me to find. The more data I'm storing that I don't need, right? The harder it's going to be for me to find something, and the more I'm going to spend on it, and oftentimes in places that you don't need to spend it.
By the way, the more data that you have that's in error, that is building up, the harder it is to push the button that says delete it. When that's 100 terabytes, it's so much harder than when it's like a gigabyte. It really truly is.
And one could argue that it makes the data set in itself less valuable, right? I mean, right? I mean, whether that's less valuable to a potential acquirer, whether that's less valuable for use internally, if I have a bunch of data that I shouldn't have and don't need, it's just going to cause issues down the road. And so making sure that, one, you're storing what you need to store and you're saving it for an appropriate, again, going down the list. What do you have? Why do you have it? Should I have it? Get rid of the stuff you don't need, right? Same thing with data as it is with infrastructure. And then go ahead.
Let's dive into because we're talking about a specific instance here of versioning, which is one of the storage cost drivers. Certainly, turning on versioning and not setting a policy, not adding a rule to manage out those versions can lead to all sorts of problems. One of them that I think people don't understand is that even if you delete an object in an S3 bucket with versioning turned on, that object is stored, plus all of its previous versions are stored forever and ever until you have a policy created that says, take any deleted or take any non-current object and actually get rid of it. So
that's a good tidbit. Yeah, people don't know. If I have versioning turned on and I have 2 years worth of versions and I go delete that file in the S3 bucket, all 2 years of those versions are still there because I'm just deleting the current object when I do that.
I'm actually marking it for deletion. It's still stored as a version. It's still there. So you have to have a policy that actually removes those. So what are the other cost drivers with storage that our listeners might be aware of, probably are, but you kind of want to holistically tie this all together for those who haven't had to deal with these? What are the sorts of things to look out for, Jason?
Well, I think along the same lines of versioning, because it's dealt with in the same sort of process, is the concept of moving data between storage classes, right? Again, I would first start off by asking the question why, right? Because a lot of times we just default to saving data, right? And we say, oh, well, we can save it all. We'll just throw it to Glacier or throw it to infrequent access S3. The first question still should be, do we need this data? But let's say we do. There are options to move your data as it ages to lower performing, cheaper storage classes within blob storage like Azure or S3, or object storage like Azure Blob and S3 with AWS. So you can life cycle it to cheaper, less expensive forms of storage. Size is also a big, the more data you store, the more you're going to pay for it. That's another big cost driver. So from an S3 perspective, we can move. Do you want to move to EBS? EBS, you're talking about, again, size, throughput, generation, and utilization all lead to the storage cost drivers. And life cycling, again, EBS volumes falls under infrastructure life cycling. That's going to be covered with you doing infrastructure life cycling to make sure that that's going. But you can also life cycle snapshots in and out. There's just a whole bunch of things that you can do from a storage perspective that should be done.
So let's break this down into a list. So versioning we touched on, of course. We also have the snapshot backup issue, which, again, having to set a policy that says you need to scrub old snapshots, scrub old backups, because you really only need a finite set of backups to get back to. So that's
right.
two.
And snapshots are for short periods of time.
Correct.
Not long.
That's right. So we also need to think in terms of storage class. So and that's true not just of S3, but also of things like EBS, where do you really need to pay for the high I/O, really rapid access,
provisioned throughput, IOPS, all that, right? Yeah, exactly.
Right. So you want to be careful there, because certainly you can create, I've done this, create code to deploy infrastructure that I need for something high performance. And then I do Control A, Control C, Control V for something else. And I didn't go and change the storage class that I needed, or other things. I've made those mistakes. So that's important as well. Also thinking in terms of generation, right? Actually, sometimes upgrading EBS volumes can result in actually lower costs. So you want to be aware of kind of costs.
Higher performance too.
That's right.
Higher performance for cheaper costs. GP2, like in AWS's case, GP2 to GP3.
Yes.
Don't forget, the over allocation, underutilization of EBS is it
happens all the time
because happens all the time. It's not. It's hey, I need to allocate 200 gig to this. People are still thinking about deploying stuff in VMware, right? And that's what it is really at the end of the day. When really in AWS or Azure, resizing a disk, even though it is like that in VMware, but resizing a disk is really easy.
Yeah, absolutely. Yeah. So let's talk about some of the techniques. I think the first thing to think about is a lot of this has to do with policy. A lot of this has to do with rules that are already supported inside the providers that will help you manage that storage. So when you think about the storage tier you're on, you can auto tier your data. You can also make sure you're setting policies for versioning in removing old versions or cleaning that up. You can set policies around your backup and how much of that continuity related data that you want to store. So that's important there. But I think that maybe some of the areas that people don't think about is when you're thinking in terms of what the data is actually used for. You can start to take advantage of the infrastructure in different ways. So for instance, if I have a temporary place that I'm staging data, let's say it's in an S3 bucket, I'm just going to use an easy example. I can actually have that S3 bucket, and I don't need to save this data. I can have processes that delete that data, but I can also have the S3 bucket. Actually, I can set a policy to scrub what's in that S3 bucket and auto remove it after a certain period of time. So I can say, hey, anything after 7 days, when it hits 7 days in age, just get rid of it because I'm not doing any more processing with it after that 7 days. That'll continue to kind of auto keep clean that storage bucket for me. It's taking advantage of the infrastructure. And honestly, in the old days of having the infrastructure inside of the data center, this wasn't really something that was available. You had to write code to go do this. Now it's sort of natively a technique that you can use.
Yes. Well, VMware loved over allocating because you paid by memory or CPU, right?
Oh, absolutely.
And the hardware vendors loved over allocating because you had to buy more compute, more hardware, right? The cloud providers love this too. But because you now pay per widget, whereas before it was kind of, obfuscated through, like I have 1,000 virtual machines sitting on hundreds of nodes and SAN. It's like, so if I'm an engineer and I go spin up a server, which we don't really need, and then I over allocate it and give it 200 gig of memory, not that many people are going to see that because there isn't a direct cost associated with that in your legacy. Well, now that you have a cost associated with everything. And so your inventory list comes with the exact cost of said thing, right? So you know when you built it, why it's there, what's the purpose, and you can do all these things. So the amount of data that we have now about our environments just lends its hand to us being able to make sure that it's running more efficiently and effectively. It's just unfortunate that we still, we don't dedicate, like you said, we're not telling the teams, engineering teams, this is important, go make sure it's cleaned up. So we have to start doing that. But yeah, I think it is something that lends its hand definitely to how cloud is utilized and built. We can now understand all of these charges, we can correlate all these things, and we can make sure we have what we should have. Which is why operating in the cloud is actually cheaper than operating internally. It's because you can actually know everything you have, what you pay for it, why. And as long as you have good processes in place, you're going to, and tools to help you do it, you're going to be in a good position.
Done well, done right, done with the right tools. It is honestly, yes, absolutely much cheaper to operate in the cloud. The problem is nearly every organization that I've worked in, consulted with, or we've talked to from a tenacity perspective has had a gap in that efficiency of managing their cloud spend. That's the real issue to address. And that's what we're trying to get to in this podcast. So any parting thoughts, Jason?
All good.
Awesome. Thanks for listening, everybody. Get out to tenacity.ai, download the Cloud Cost Optimization Handbook. We'll have all sorts of tips and techniques just like this inside of that handbook, constantly updating it with ways that you can proactively manage your environment. And, always looking for feedback from the community as well. Thanks for listening, everyone.